Hello, this is Chinmay from Subnero, and in this video we'll be exploring how to work with underwater networks or Unet using UnetStack3. Let's get started. If you haven't gotten set up with UnetStack yet, please watch the Getting Started video. It will help you get your machine set up with UnetStack3. For this video, I'll be using the 2-node network, the exact same simulation that we used in the previous video. But don't worry, all the commands and functionalities that we'll explore in this video will be exactly the same if you use a real physical modem. Let me start the simulation. This will give me 2 simulated nodes. I'm going to open the web shell for each of the nodes. This is node A and this is node B. UnetStack uses datagrams to send data between nodes. Datagrams need to be addressed to individual nodes within a network. UnetStack does this using addresses. This is very similar to addresses in an IP network, except that UnetStack addresses by default only run from 0 to 255. You can find out the address of any node running UnetStack using the node command. Let us check out the addresses. So on node A, if I type node, I'll get the address. And in this case, you will see the address of node A is 232. And the address of node B is 31. You can change the address of any node anytime during the deployment by setting the address like this. Now we have changed the address of node A to 61, and we can easily change it back to the original one, which was 232. Just remember, if you have multiple nodes with the same address in a network, that will cause address collision. We really want to avoid that. While addresses are critical for Unet links to work, they're very cumbersome for users to remember. That's why UnetStack has the notion of node names, which can be set to descriptive strings for us to easily remember and identify nodes. Node names can be also set and get at any time during the deployment, just like this. I'm setting the node name for node A now. Originally, the node name for node A was A, and I can easily change it to something else. Let's say buoy A. And now the node name for node A has now changed to buoy A. UnetStack also provides an address resolution service. The address resolution service helps you map between node names and node addresses. The default address resolution service in UnetStack3 is a simple hashing algorithm that maps a string to a number. Since this is a simple hashing algorithm, it doesn't require network access. The simplest way to use the address resolution service is using the host function. The host function will map a string to a number. We can use the host function to generate an address for a node using its node name. Once we have done this, on any other node, we can use the same host function and find out the address of any other node using its node name. Let me show you. On node A, I'm going to set its address to be the number resolved by the host function based on its node name. So now node A's address is set to 235. To be able to find the address of node A on node B, we can easily use the host function and give it the name of node A, which we have recently changed to buoy A. And that will also give us 235. This way we can actually find the address of node A from node B without actually knowing the address by just knowing the name. Until now, we have seen how to address a specific node in a unit. However, there might be multiple services, agents, or end-user applications running on any given node. Normally, we want to send a datagram to a specific application or a service on a given node. UnetStack supports this with the notion of protocols. Protocols are very similar to ports in the TCP/IP or UDP/IP world. And UnetStack3 supports 64 protocols numbering from 0 to 63. Protocols number 1 to 31 are reserved by UnetStack for its internal usage, and the rest of them are available for end-user applications. Let's see how we can use protocols to send datagrams to specific applications running on the other node using the UnetSocket API. On node B, I'm going to create a simple application with a socket listening to protocol user, which is protocol number 32. On node A, let's send a datagram to node B, but to another protocol. Let's say protocol data, which is number 0. But since we're sending the datagram to the wrong protocol, the socket we created on node B will not receive the datagram. As you can see, even after a few seconds, node B does not receive any datagrams from node A. That's because the datagram was sent on the wrong protocol. Now let's fix that and send the datagram from node A to the right protocol on node B and see if node B receives the message. This time we are going to connect the socket to the right protocol, which is protocol.user, and we will send the same message again. And as you can see, within a few seconds, node B receives the datagram from node A. You can quickly look at the contents of the datagram, and we can see that it has the data that we had sent from node A. This is how you can use protocols to send datagrams to specific applications within a single node. Cool, so now you know some basic tools and utilities that UnetStack has built in. Go ahead and try them out. And if you have any comments or suggestions or questions, don't forget to leave them in the comment section below. Thank you and see you next time.